Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about arc lengths and sector areas. To start off with, we're going to talk about arc length. So if we took a circle with a radius of r and took a section of that circle defined by this central angle that we'll call theta, the arc length of that sector would be the distance along the circumference from this point to this point. Now we know in a circle, or in a complete rotation, that distance is called circumference. Circumference is defined as pi times the diameter, or circumference is also defined as 2 pi times the radius. So depending on whether you're given the radius or the diameter, you can use either formula. And the reason that they're the same is because 2 times the radius is equal to the diameter. We can find this length in this section by using proportion. And the way that we do that, the ratio of this length to the total length around the circle will be equivalent to the ratio of this angle to the total angle in the circle of 360 degrees. So the ratio of the arc length, L, to the total circumference, or the total distance around that circle, will be equivalent to the ratio of this angle, central angle, to one complete rotation. So in other words, we can write this as L over the circumference, which 2 pi r, will equal the angle theta over the complete rotation of 360 degrees. Let's take a look at an example. In our first example, we have a circle that has a radius of 50 centimeters and the central angle is 110 degrees. So we want to find this length here along the circumference. So that's going to be L. The circumference will be 2 pi times the radius of 50 centimeters. The angle is 110 degrees and complete rotation is 360 degrees. I'm going to drop units understanding that this length will also be in centimeters. And I'm going to, since both angles are in degrees, I'm going to drop those. So this is going to be L. I'm going to simplify 2 times 50 is 100 times pi will equal 110 over 360. In order to find L, I'm going to cross multiply. There's 2 ways I can cross multiply. I can do, the first way is by writing everything down. So I multiply my diagonals, 360L will equal the product of that diagonal, so 100 pi times 110, and then I divide both sides by 360 to get a result of 96 centimeters. The other way that we can cross multiply, which is a bit of a shortcut, is we could just simply take the numbers that are diagonal to each other, so 100 times pi times 110, and then divide by the number that's on the diagonal with L. So just in one fell swoop, you can do this, divide by this to get your result. So if you want to shortcut it, you can. If you want to write down your steps, you can. It's personal preference. So the length along that circumference, or that arc length, would be 96 centimeters rounded off. Now let's talk about sector area. Sector area will be the area of that slice created by that angle. Again, it's going to be a proportion. We could find the area of the whole circle using the formula pi times radius squared. So that will give us the total area here. In order to find the area of this sector, I'm going to use proportion again. So that proportion will be the sector area to the total area of the circle will be equivalent to the ratio of the angle, theta, to the total revolution, which is 360 degrees. So I'm going to use the letter A for the sector area, not to be confused with this formula area of a circle. And then I'm going to put the area of the circle, which is pi r squared. And that will be equal to the ratio of my central angle to the complete rotation of a 360 degrees. Let's take a look at an example. We're going to use the same dimensions in this example as we did with the previous example when we were finding arc length, except now we're going to find the area of this sector. So in order to find that, I fill in my proportion. So this will be pi times 50 centimeters squared. And that will be the angle of 110 degrees over 360 degrees. Understanding that my area of that sector will be in square centimeters, because this total area will be in square centimeters, I'm going to drop the units just to make it look a little easier. So I'm going to have A over 50 squared is 2,500 times pi will equal 110 over 360. Again, we're going to cross multiply, so we can do it step by step. So 360 times A, I take that diagonal, will equal the product of this diagonal. So 2,500 pi times 110. And then I'm going to divide both sides by 360 to isolate A. When I do that, the 360 will cancel here. So A will equal 2,500 times pi times 110 divided by 360, which is equivalent to 2,399.8 square centimeters, which you might want to round off to 2,400 square centimeters, depending on how accurate you need to be. Again, when I'm cross multiplying here, I could just take these numbers that are across from each other, just plug those in, this times this, and then divide by this. You don't necessarily have to write those steps down. These formulas or proportions work regardless of the size of the circle or the angle.